Algebra, lesson 20. Second to last lesson of the unit. Changes over equal intervals. Let's warm up our brains. For each given expression, write an equivalent expression with as few terms as possible. So number one, I think we're just going to collect some like terms. First, I need to distribute this, which gives me 7p minus 3 plus 2p plus 2. Then I can collect my p's, and I get 9p, and negative 3 plus 2 is minus 1. Number 2, ooh, that's messy. Looks like I'm going to first distribute that. 4n plus 4 plus 10, because that's all in the brackets. That all needs to be there. And then I can distribute this also, but I need to distribute the negative too. So minus 4n minus 4. Those 4's cancel out, and I'm left with 4 plus 10 minus 4, which is just 10. So they're equivalent because they're equal to each other. Here, 9 to the 5th, 9 to the 2nd, and 9 to the x power. Remember, when we have the same base, which is 9, I add the exponents. So I'm just going to say 9 to the 5 plus 2 plus x, which I can simplify further, 9 to the 7 plus x. And then number 4, when I have the same base, which is a 2, I can subtract the exponents. So 2 to the 4n minus n, which I can simplify further, 2 to the 3n. Okay, that's really reminding ourselves of some tools from pre-algebra. All right, this got really small, so I'm sure I'm going to need to make a few duplicate slides of it. Here is a graph of y equals f of x, where f of x equals 2x plus 5. Okay, that is a linear function, right? Excuse me. So to look at this first, how do the values of f change whenever x increases by 1? For instance, when it decreases from 1 to 2 or from 19 to 20. Be prepared to explain how you know. So I have f of x equals 2x plus 5. If I rewrite that, y equals 2x plus 5. When my x value increases by 1, so for the instance it says from 1 to 2. If I have from 1, so 2 times 1 plus 5 is 7, and 2 times 2 plus 5 is 9. So when the x value increases by 1, the y value is actually increasing by 2, which is also our slope. We go change in y of 2, change in x of 1. Change of y of 2, change of x of 1. Okay, 2 over 1, 2 over 1. That is just our slope, right? What else can I tell you? I can do the same thing for the from 19 to 20. Okay, it'll still just be a y change of 2, right? So that's done. Number 2, here is an expression we can use to find the difference in the values of f when the input changes from x to x plus 1. So I take that equation, which was 2x plus 5, and I'm changing it from x to x plus 1. So I'm going to rewrite this just with some colors. So 2, instead of x, I'm going to do x plus 1 plus 5. So that is the first equation, and then I'm going to subtract 2. I did it again. X plus 5. okay? We're going to ignore 3 for now because I'm not going to have room for that. But if I go ahead and find an equal representation, I'm going to distribute that to 2x plus 2 plus 5. And then I'm going to distribute this negative, which is very crazy, I know, but we always have to distribute negatives when they are in front of parentheses or brackets. If I collect like terms, I see that my 2's cancel out and my 5's cancel out. And the only thing I have left is a 2, which is the same 2 that I found for question number 1. Okay, the y value changed changed in 2 by an increment of 2. Sorry, I lost my words there for a moment. When x changes in an increment of 1, y changes in an increment of 2. Okay, we just proved this with number 2 using a very, very fancy equation. All right, so with 1, we just plugged in numbers and found it ourselves. With 2, we plugged in more of an equation and found our answer. So does this expression have the same value as what you found in the previous question? Yes. Show your reasoning. I showed my work, and I found that I had a 2 left over when I simplified. All right, number 3 says, how do the values of f change whenever x increases by 4? Explain or show how you know. Okay, I need another piece of paper. So our function is 2x plus 5. So now x is changing by 4. So let's do the same thing. I'm going to have my function 2, but instead of x, I'm doing x plus 4. And I want to subtract my original. I want to see what my value of y is going to change. So let's distribute this. I have 2x plus 8 minus 5. And then I need to distribute the negative, because when there's a negative in front of parentheses, I always have to make sure that negative is distributed through. Now collect like terms. And it looks like my value of y changes by an increment of 8 when x changes by an increment of 4. Hey, guess what? 2 times 4 equals 8. Okay? When x changed in an increment of 1, our y value changed in an increment of 2. So now x is changing in an increment of 4. Y is changing in an increment of 8. Okay, it's linear, so it's going to be incrementally equal, which is kind of cool. Let me look back at the problem. Show or explain how that expression has a value of 8. I did. Did we answer all those questions? I think we did. Yep. Here is a table that shows some input and output values of an exponential function g. The equation g of x equals 3 to the x defines the function. I think I had to cut off the questions here too. Hold on, let me find them. How does g of x change every time x is increased by 1? So here x is increasing by 1. G of x, how is it changing? Can we figure that out? It looks to be a times 3. So 27 times 3, 81 times 3, 243 times 3. I would challenge you to get your calculator out and double check that. But that is what is happening. So the output values increase by a factor of 3. How we used to figure that out was, when we first learned this, we would do 729 divide by 243. And then we would do 243 divide by 81. And then we do 81 divided by 27. And we get the same factor every time, right? All right, let's look at number 2. Okay, we finished number 1. Choose 2 new input values that are consecutive whole numbers and find their output values. Record them in the table. How do the output values change for those 2 input values? All right, I need a new piece of paper, but you have that in front of you. We're looking at number 2. Okay, so we're on number 2. So let's just find some. If we look at, let's do g of 10. That would be 3 raised to the 10th power. And then g of 11, which would be 3 raised to the 11th power. The output would still grow by a factor of 3, because remember, this is what we were doing. 3 to the 11th over 3 to the 10th. And when I have the same base, I subtract the exponents. Same growth factor. Okay, nothing has changed. The output is still growing by a factor of 3 when the input is increasing by 1. So our input is only increasing by 1 from 10 to 11. So the x is increasing by an increment of 1, and the y is increasing by a factor of 3. That's what that x is. It's the multiplication. That's a little confusing, isn't it? By a factor of 3. All right, number 3 says, complete the table with the output when the input is x and when it's x plus 1. So if this would be number 3, if I have x and g of x, I'm going from x to x plus 1. So here's my table. My g of x is 3, and then my next g of x would be 3 to the x plus 1. And I know that's true because if I do that same division, when I have the same base, I subtract the exponents. X plus 1 minus x equals 3. Okay, it works. It's pretty cool if you ask me. All right, let's do another slide. Number 4 says, look at the change in output values as the x increases by 1. Does it still agree with your findings earlier? Show your reasoning. Yeah, I got ahead of myself. And that's where we had 3 to the x plus 1 over 3 to the x. Okay, same growth factor. Number 5, choose 2 x values where one is 3 more than the other. For example, 1 and 4. Let's just do this. So when x was 1 and 4, I would have 3 to the first power and 3 to the fourth power. 3 to the fourth power is 81. So 81 over 3 is 27. 27 is the same as 3 to the third power. So they are also equivalent. When I increased by a plus 3, my factor changed by a 3 to the third. So everything is holding consistent. There's a lot of questions in this problem. Number 6. Number 6 says, complete this table with the output when the input is x. Sorry, I had a little tickle. I had to cough again. Okay, our table is x and then x plus 3. We would have 3 raised to the x power and 3 raised to the x plus 3 power. And the same thing we've done. I'm going to do that division to find my factor. When I have the same base, I subtract the exponents. And that gives me 3 to the third power. So when this increases by a plus 3, this changes by a factor of 3. I just think math is so magical. You may disagree with me. That's actually all we had for today. Good work. One more lesson, and then we're done with the unit.